So the rest of this section isn't really any different than the beginning, other than I attach some words and try to make the problem slightly more realistic. For problem 8, I just looked up the alcohol content of a bunch of beers relative to their calories and made a table. We're going to plot this in list 1 and list 2, find an equation of a line that fits the data, see if it's linear or not. I'm not a particularly big drinker. I don't have any alcohol in my house right now. Not that I'm against it. I have a couple drinks a year. Anyways, this problem makes me think of a story. Back in the 80s, Metro Center was happening, believe it or not. And I went to Thunderbird High School, so I've lived here forever. And the drinking age was 19 back in the day. So this would have to be in 1983. I was at a Bennigan's at Metro Center. All the NBA teams used to stay at the hotel there by Metro Center back in the 80s. And I had 2 drinks, a Tom Collins and something else that tasted like lemonade. And my buddies, who I'm still friends with, tell me that I started kind of swaying on my chair. One of the Celtics, Boston Celtics, was there, a guy named Robert Parrish, and I'd never go up and ask anybody for an autograph, but I went and asked him for an autograph. Got it because my sister lives in outside of Boston in Cape Cod. Got him that autograph, and then a few minutes later, I told my friends, I just need to go outside, and I promptly went outside, and there was grass in front of Bennigan's back in the day, and I just passed out on the grass, and maybe that's why I don't drink so much. Anyways, not that it has anything to do with this problem, but this problem right here, it gives me data. This is kind of almost a distractor, the brand. The important parts are the alcohol content and the calories. It says make a scatter plot of the data. You can leave the alcohol content written as a percent. So I'm going to leave the alcohol content written as a percent. And I'm going to come up with an equation to fit the data. So let me go into my calculator and clear out my list 1 and list 2 because I don't think this list is going to accommodate 7 numbers. Well, it would have. And in list 1, I'm going to put the 4.7% alcohol and 6.7% alcohol, 8.1, 4.15, 5.15, and 6.2. Super easy to skip a number, write a number wrong, and then all of a sudden that makes your work wrong. If your equation comes off a little bit because you have, entered something wrong, I won't kill you with a lot of points off. That's not so important, but it should check real quickly. When I was writing the keys to this, I would just do the lines on both calculators. Let me do a stat plot right now. That's what part A says. So zoom, stat. I might not even see the old line, but I might. I didn't take it off. Don't see the old line. Well, maybe I didn't. It's there. Just didn't show up. Let me clear that out of there anyways. All right, so that's part A. Make a scatter plot. C calculator. We're not doing any graphing by hand. Now find my equation. This calculator is easier, so that's why I've got it out. Stat, calc, linear regression. Go down to the store regression equation. Vars, y-vars, function y1. Again, that's vars, arrow over to y-vars, hit enter on function, hit enter on y. I might have it twice here now. Now I did do that. On this calculator, I'm not going to enter the data, but calculator button pressing, it's stat, calc, linear regression, and then second L1, second and 1 for L1, comma, second and 2 for L2, comma, vars, y-vars, enter on function, enter on y1. On this calculator, I can just hit enter now. On this calculator, I got to roll down to calculate and hit enter. When I roll down to calculate, this calculator will give me a good equation. This won't because I didn't enter the data in it. It'll just give me the equation for the last data. So I'm not going to hit enter on this. I'm going to just clear this out. But that's what you need to have if you have an older calculator like this one. So round to 2 decimals. For part A, my equation for this is y equals 27.05x plus 19.79. And in this case, the X is the alcohol content, the Y is the number of calories. And the question is, how strong is the relationship? Well, the R is 0.91. For 0.91, that's a very strong relationship. So there's a very strong linear relationship between the alcohol content of beer and the number of calories. So here, it's a very strong relationship. Then it asked me to graph it. I don't want you to do any of these except just inspect your calculator. I stored it in Y1, so now when I hit my calculator, it makes a graph. The closer the R is to 1, the less stragglers you have. You know, I have a few points here that are a little bit straggled from the line, but it's still reasonable for predictions. So now, part E, predict the number of calories in a 12-ounce beer. These are all 12-ounce beers calories. Predict the number that has 5.5% alcohol content. Y is the number of calories. I'm going to leave the number as a percent because that's how I entered the data. And if I look at this number, 5.5%, well, here's my, 5%, there's my 5.1%. Boy, I bet you it's not going to be over 195, it's not going to be under 158. I'm just going to enter this on either one of my calculators. Hit second and quit, get back to the main screen. Type in 27.05 times 5.5 plus 19.79. It gives me 168.56 calories. I'm around 57 calories. Again, I probably should have said round to the nearest whole number, but I'm going to say it's going to have about 168.57 calories. I should have just said round to the nearest integer and said 169 calories. But in the beginning of this section, I just say round to 2 decimals mindlessly. So that's what I'm going to write for an answer. And this feels good because, if there really is a linear relationship, meaning the more alcohol, the more calories, then that just kind of fits perfectly. So your problem, we've got a couple more problems to do. And I almost feel like we should do problem 7 together, just because it's a little bit different. And well, I don't know why I call it, this is 7, I guess, yeah. Felt like we're deeper into this section than problem 7. Anyways, let's do this one together. Same idea, except it has years. I don't like putting problems with years because it dates the material so quickly. I just rewrote this section. I hadn't rewritten it for about 6 or 7 years, maybe 8 years, and all these problems with years got dated. So I scrubbed out the problems with years and put in problems that didn't have years. But I'm going to retire in about 4 years, so this won't have a chance to get old on me. Maybe 6 years to be the outside of when I retire. And this, I tried to set this problem up so even in 6 years it wouldn't be that far off. So this problem, number 7, that's not my verbiage right there. I had to clip this from something on Google that I searched. It says, so as the Earth population continues to grow, the solid waste generated by the population grows with it. Governments must plan blah 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 blah. Anyways, that's not blah blah blah. I'm a big green liberal person for what that's worth, and boy, I hate plastic waste. I hate what we're doing to the oceans and how it's just horrible. Anyways, that's why I put this on here, not making light of. I despise litter and wish we could come up with a better way to not litter and not use so much plastic. But anyways, I shouldn't be preaching politics here. Anyways, this table gives me for each year, for every 10-year increment, how much plastic waste in thousands of tons. So if any number here, this means this right here, this 6830 means this many tons. This means 6,830,000 tons. And of course, if I multiplied that by 2,000, because there's 2,000 pounds in a ton, I'd get how many pounds of plastic waste there were just in 1980, where we weren't generating, the kind of waste that we did. I don't even know if I could do this in my head. I think this is it. So that's what, 13 billion 660,000 pounds of plastic waste in 1980, and we're way worse than that now. And so that's what these numbers mean. If I wanted to convert these numbers into regular tons, I'd add 3 zeros. If I want to change the tons into pounds, I'd multiply by 2,000. Not necessary, but this isn't how many tons. This is how many thousands of tons. So first of all, it asks me to make a scatter plot of the data, and it says let x be the number of years represent 1980. So instead of 1980, I'm going to put 0 on my calculator, and instead of 1990, I'm going to put 10 because it's 10 years after 1980. Instead of the year 2000, I'm going to plug 20. It's 20 years after 1980. And then now we're getting to where some of you were born. 2010, we put a 30 in for. And 2040, I found data, but not for 2020, so I just called this estimated. And let me enter these in list 1, these in list 2, make a scatter plot of the data, find an equation of a line that fits the data, see if it's a strong relationship, graph it on my calculator. So for A and D, it's going to be purely on my calculator. I'm not doing any graphs by hand. And then plug in something to represent 2030, and 2030 is going to be 50. So I'm going to let x be 50. If I'm using y and x. If I wrote something with a function notation, boy, I could use something, I could write something nicer. Let me do this on my older calculator. Not that it matters, but so stat, edit, clear the list, go up to the top and hit enter. Go up to the top of the list, click clear and hit enter. Now 0, 10, 20, 30, 40, and 6830. 17130 25550 31400 37500. There's a reasonable chance that even in one of my equations earlier it's been wrong because I didn't enter a number right. So if your number didn't match with my number, check to make sure your numbers were entered right. If you entered them right, then I probably entered them wrong. It's just a button pressing error. Super easy on a test to make a button pressing error. So let me just zoom stat this now. Zoom stat. Here's my scatter plot. That is pretty linear, at least over that small 40-year window. So that's that. Now let me find my equation on this calculator. Find the equation of a line. I go stat, calc, over to linear regression, and then second L1, comma, second L2, which is on 2, second 1, second 2, comma, vars, y vars, function, enter. In my equation, I'm going to round to 2 decimals, and that's a really strong relationship. So for part B, y, the amount of plastic waste, equals to 756.1 x plus 8560. Wow, that came out so nice. If we wanted to, I might be able to do this. P stands for plastic waste. T stands for the number of years. The amount of plastic waste in T years is 756.1 T plus 8560. That would be maybe a nicer way to write the equation rather than writing it with a y. But a y and an x are fine. Now that I've stored my equation in y1, if I hit my graph button, it shows me, boy, that line goes really tightly through the data. That's why the R was so high. The R was 0.99. So this is super strong. It's very, very strong. It's almost equal to 1. 1 is a perfect fit. And did my scatter plot. Now I'm going to use it to predict how many thousands of tons of plastic of waste we'll have in the year 2030 by plugging 50 in. I'm going to go 756.1 times 50 plus 8560, and we get 46,365,000 tons of waste, of plastic waste. I don't know if it's the worst kind, but it's right up there. I think it is. Maybe radioactive waste is worse, but anyways, it's bad. And that's all there is for that problem. I don't think I'm going to do another one, which means we need to get our calculator so it's not going to mess us up. So let's get our calculator working in a good way. Once you're done doing, once you're done graphing, go to the y equals screen, get your cursor, get it blinking on list 1 and hit enter. Pull it off of list 1. List 1 will be now not highlighted. That's a good place to be. Here I've got my cursor blinking on list 1. I'll hit enter. That's a good place to be. If you need to turn it back on, you can just go up to that plot, hit enter. Nope, you have to go second and y equals, and then turn the plot on. And there it's on. Go back to y equals. It's going to be darkened again. Now go back up to this. I can toggle it off. And also, I'm going to get my window back to a standard window. It's a bizarre window that's in there right now. So I'm going to hit just zoom and go down to option 6. That's the standard on both of my calculators. Just so that if I pick my calculator up in the next time I go to use it, so it's not set up to do something that is going to make me make mistakes. So that's everything for this section. It felt like an easy section, so hopefully that kind of you felt the same. We'll stop the video and we'll plow on.